Hello everyone, my name is Dmitry Soshnikov. I am Cloud Developer Advocate at Microsoft, and it's really my great pleasure to open Microsoft Stage Conference today. Normally at a Microsoft conference you would have the opening talk dedicated to the cloud, talking about different features of the cloud and why it is good to use the cloud. So instead of giving this complete overview of our platform, I will focus now on one particular example of how cloud made me personally do some great things. And to set the context, so what I do at Microsoft is I talk at conferences, I write blog posts, and one big part of my job is to provide product feedback to our internal development teams. So if you, for some reason, think that Microsoft Azure is not the best cloud solution and you have some specific things like why it's not the best, you can talk to me and I will pass this feedback on to our development team so that we become better. I used to work in Microsoft as software developer as a part of commercial software engineering, and as part of this group I did some pilot projects on AI and machine learning with big European companies. So I have some hands-on experience with our cloud. And what I also do, I teach in a couple of universities in Russia. I teach artificial intelligence and functional and logic programming. And so what I will be talking about today is related to another part of my life connected to science art, because my daughter, she goes to art school and she also goes to math school and learns programming. I also like exploring something on the intersection of software development and art, and this is one specific direction of science art related to computer science. And you can see some of the works that I produced using neural network training and some other technique called people blending. So today my main idea would be that cloud allows you to bring your ideas to life very easily. And cloud consists of some smaller building blocks like Lego, which you can put together to achieve any result you want. And in particular, I will focus on science art, how cloud can help us create some kind of exhibits and art objects using those building blocks. So let me first talk about the cloud in general, like how can you view cloud overall. So cloud, of course, is something based in the data center. So in the data center, you have a lot of hardware, and you can easily borrow this hardware. So the two basic components of the cloud are compute, basically virtual machines and servers, and storage, the ability to store any amount of data. And those components are called infrastructure as a service, because essentially you are buying an infrastructure. You are buying the virtual machines, you are buying virtual hard disks. There are, of course, different types of compute, like starting from very simple one, a virtual machine, essentially a computer which you can easily create in the cloud and then delete. And there are also some things like batch clusters. For example, if you need to process a lot of information in parallel, you can spin up a lot of virtual machines and they will be managed as one entity. And also, like, you can use Kubernetes cluster to easily deploy your microservice architecture if you have some complex projects defined in terms of microservices. Also, in terms of storage, there is some basic Azure storage, which allows you to store binary data, blobs, files, tables, and queues. And also, there are some more structured ways to store data. For example, Azure SQL is the SQL relational database. Cosmos DB is it's a kind of NoSQL offering, very flexible NoSQL offering, where you can store JSON files. You can also store some kind of tables, but schemaless without hardly imposed schema, and data lake for big data storage. So this is called infrastructure as a service because those services are closely related to hardware. In addition to that, you also have the platform as a service offering. And with platform as a service, the idea is that you do not take care of all the small details, like which virtual machine I will need to put the software on. But rather you think in terms of things you want to accomplish. For example, if you want to host a web application in the cloud, you would just say, I want the Azure web app. And if you create an Azure web app, all you need to do is to upload your code and it would be available as the web server in the cloud. It's that easy, and you don't have to take care about which web server software to put on it, like how to update those versions, and how to scale it, because you can set some kind of scaling options which would take care of different loads. If you want, instead of web app, create a chatbot, you have Microsoft Bot Framework and Azure Bot Service, and you can create chatbots by essentially putting the code behind it in the cloud, and without thinking how everything works together at low level. If you just want some piece of code to be executed in the cloud, this is called Azure Function. Azure Function can react to some kind of events and execute some pieces of code on demand. And also there are solutions for Internet of Things, like if you want to process a lot of messages from different devices. There are solutions for machine learning called Azure Machine Learning, and Databricks for big data. And on top of that, there is even more layer of platform services which are focused on very specific tasks. I will call them here platform as a service plus, because they are very specific, and essentially they are pre-trained neural network models which help you solving certain problems. For example, there are services called cognitive services which provide support for computer vision. You can pass the picture to this service and it will give you the description and different metadata from this picture, like how many people are there, what is their age, what are their emotions, and so on. So there are also services related to computer to face detection, to dealing with text, for example, detecting intents in text, or detecting sentiment, how positive or negative certain pieces of text are, and so on. And there are even services that allow you to build question and answer chatbots based on textual data. Finally, there are also two interesting offerings for low-code development, which are called power-ups. Power-ups allow you to compose those building blocks together even without coding completely. Like, for example, if you want to set up a business process where you would expect a partner to take a picture of a document, and you want to extract some data from this document, for example, names of people or their contact information, and populate that into a database. That can be done automatically using power-ups just by drawing the pretty much the information flow diagram. And Power BI is similar project for business intelligence, for building, for comparing data and building the dashboards, database dashboards. So that was a lot of information. If you want to go deeper into details on any of those topics, you have the links available here on the slide. And I do not expect you to remember that, because there is just one link at the top, easyfi.net/azref, Azure reference. And with that link, you have all those links also available, and you can study them if you want specific information on any of the services. So let me now come to the main topic of my talk. So as the science artist, as the person thinking how can I use artificial intelligence to create something interesting, I came up a nice idea. So the idea occurred to me that we can create so-called cognitive portrait by taking a lot of pictures of one person or of different people, and aligning them together automatically in such a way that faces occupy the same position in the picture. So if we align all the faces in such a way, for example, that eyes occupy the same position, then we can create this kind of blended portrait. And if we blend different pictures of one person, we create the blended averaged portrait of that person. If we take, for example, different people, we can create the average portrait of a visitor to a conference, for example, or average portrait of a student in the university, or something like that. So how can we do that automatically? Well, Azure can help us do that, because this thing, actually creating this portrait, is based on two ideas. First of all, is extracting so-called facial landmarks. And facial landmarks are those specific points in the face, like eye coordinates and mouth coordinates and different other points. And neural networks now can do a very good job extracting that information from a picture. So if I wanted to do it like manually without using the services in the cloud, I would have to train a neural network to do that. or find a pre-trained neural network to do that. And that's possible to do it. There are some publicly available models to do that, but I would need to spend quite some time learning how to use them and how to set them up. Instead, if I use Microsoft Cognitive Services, they provide me this information just using one REST API call. So it is as easy as passing the picture to the service, and it gives you back all the required information. And the second step is doing so-called affine transformation. If I know the coordinates of the eyes, I can apply the transformation to the image, which brings eyes to the pre-specified position. And this can be done using OpenCV library. And there is, as you might know, there is a very good Python binding for OpenCV. So essentially, you can write a small piece of Python code to do all that. So now I just need to put those things together and put some Python code to work to create this portrait. So this is the first thing that I did. And let me show you in more details how it works. So first of all, let's talk about cognitive services. As I mentioned, cognitive services are pre-trained models which can do some kind of very clever tasks which is done by pre-trained neural networks. So those are services which kind of double human cognition. So they do things that typically human beings are good at. For example, reading the text, extracting the information from the text, trying to figure out the intent of the user from his phrase, or looking for some keywords, those kind of things. And there are services which are related to vision, to speech, to language processing, to knowledge, and to also to clever search. And I would not go into detail because if you want to go deeper, you have the link here on the slide, and you can always read about them. I will just show you a quick demonstration at how they work. So here we can go to microsoft.com/cognitive, which is like the homepage for cognitive services. And if we scroll down, we see all the services right here on the web page. So let me show you how the computer vision works. We'll just try the first one, computer vision. And the good thing is that you can try this service right here from the web page. You see how the service, what kind of information it extracts from the picture. So let's take this picture of 3 women. You can see that computer sees them as people. It sees the laptop, and on the right there is the JSON file that programmer receives, including even the text-based description of what's on the picture. You know, that's kind of magic. The computer can describe in the normal human language what is on the picture. We can also upload any picture you like. So, for example, here is the picture of myself, and it tells you that this is Dmitry Soshnikov holding a sign. You know, that cognitive services recognize me by name, and I'm very proud of that. It also gives you the gender, the age information, and so on. So in the same manner, you can use cognitive service to extract the facial landmarks. So now we know that there are those services which can provide you the existing solution to your problem. So the second thing that I need to do is I need to be able to run Python code to create this cognitive portrait. So how can I do that using the cloud? For that, I can use the technology called Visual Studio Codespaces or GitHub Codespaces. So the idea of Codespaces is that, normally if you want to run some kind of Python code, you would probably install the Python environment locally on your machine, and the most probably you would use Visual Studio Code, because Visual Studio Code is the best text editor available, and most programmers, especially those who are familiar with Microsoft platform, they definitely love to use Visual Studio Code. So with Visual Studio Code and local development, of course, you can do that. There is a very good Python extension for Visual Studio Code, but the good thing is that you don't even have to install anything locally, because there is a technology called Codespaces. The idea of Codespaces is that you can easily create the snapshot of the repository in the cloud and run your code directly from your browser. So that's what we will do now. We will try to create the cognitive portrait, and I have the link to the repository which contains all the data. It's here on the slide, so you can repeat all the steps that I will show you. Well, you can even try to do it now, or you can do it later on. So let's start from the repository. Here it is, GitHub.com Cloud Advocacy Cognitive Portrait. And in this repository, there is a collection of different cognitive portrait samples, which some of them have been created by me, and some of them have been created by some other members of the community. Sometimes I ask my students to develop some kind of new technique for combining people faces together. So you can, in fact, if you want to play with it, you can also contribute to this repository by issuing the pull request. So if I want to run the code from here, I can immediately do it using this code tab. And if I have access to code spaces technology, which right now requires some pre-approval from GitHub, but you can request it, and you would have the same functionality available to you. You can select open with code spaces. And here you can either create a new code space, and that would spin up the small containerized virtual machine with your specific environment. But in my case, I have the existing container, so I will just open it. And even to save some time, I will use the already opened one. So here you can see that I have the familiar Visual Studio Code environment inside the browser. Luckily, VS Code is the web-based technology, so you have all the functionality from Visual Studio Code here, including all the extensions like Python extension and so on. So the first time you start it up, it will take some time to install those Python extensions, but in a few minutes you would be able to enjoy notebook experience right here from Visual Studio Code. So here I can open the main Cognitive Portrait IPNB notebook, and essentially it describes all the steps required to create this portrait. So you can try it yourself. I will not go too deeply into details. I will just note that to call the cognitive service you would need the special key. And the special key can be obtained either from your Azure subscription if you have one, or if you don't have Azure subscription, you can request the trial key by clicking here. And it will take you to a separate page where you can provide your Microsoft ID and get the trial API key. So you would put your API key and endpoint here. And after you do it, you should be able to call cognitive services with just one function call. So let me execute this cell. You see, I provided it with the URL to some picture available on the internet. I asked to return facial landmarks, and here it is. It gave me the coordinates of all the required points. So now I can take the bunch of images. In this example, I take images of Bill Gates, which are available here inside the repository. You can use them, or you can upload your own images here if you want to create the portrait of your own. And then I take this path and I process all the images in this directory. So you can see, for example, here is the first image, and the red dots indicate the facial landmarks that Cognitive Service has discovered, just to make sure that everything works correctly. So now what I need to do, I process all those images in a loop. You just need to be a little bit careful. If you have the trial key for the cognitive service, it would limit the amount of pictures you can process per minute to 20. So that's why here I just take the first, for example, 13 images and not use all of them, so that I don't get these limitations. So finally, I can display to see how those images look like. Here we are. We have the pictures of Bill Gates. Now we need to rotate them. To rotate them, I would use the affine transformation. I have already talked about that. It's very easy to do that using OpenCV. So I will transform all the images, and you see here they are those images rotated in such a way that eyes occupy exactly the same position inside the picture. So finally, I just need to put all that together. I define one more blending function, and here you have the result of blending two pictures together. And if I blend all pictures together, I will get this beautiful cognitive portrait that you have seen earlier. You have seen that it's very easy to start with GitHub repository and execute the code inside and make some changes without even installing anything on your local machine. So my ask to you is that, first of all, request the access to GitHub code spaces using the link here on the slide, and then try to experiment with this code. And if you come up with your own way to compose faces together, submit a pull request. So that was my original idea, but then I thought how I can do something more interesting around it. And around the new year, one of the museums in Moscow called Electro Museum, it opened the so-called call for content for an open exhibition. And I thought of creating some kind of interesting technology around this cognitive portrait idea. And what I came up with is creating the exhibit which would take pictures of people and blend them together into the averaged portrait of a person. You can see the sample of this exhibit working locally, and me and my daughter trying to to take pictures of ourselves to create the blended portrait of two of us. So that would work in the same manner inside the gallery. So how this thing would work architecturally? Architecturally, I would have the local application which runs at museum, either using some kind of personal computer or Raspberry Pi. It can be a UWP application which takes pictures as soon as it sees somebody in front of the camera, and once it has the picture of a person, it sends it to the cloud to do all the job with creating the portrait. So it would store the picture inside the blob storage in Azure. It would take the previous pictures, mix them together, and return the result. And this can be done using Azure Function. As I mentioned, Azure Function is the easiest way to execute the piece of code somewhere in the cloud. And moreover, if I want, for example, to install this the same kind of exhibit in a different gallery, I can do that easily, because I would just have different front end, and it would call the same Azure Function backend. And by doing so, I can even create a very interesting exhibit which will mix together, which will blend together visitors from different museums in real time. I think that's the great idea. Let's see how it can be implemented in software. So first of all, let's start with UWP client application. Why I want to use UWP as the client application technology? Because UWP supports automatic detection of faces. I don't want to send like all pictures of every second, for example, to the cloud, because it would take, first of all, the extra amount of traffic, more time, and the calling cognitive services also doesn't come for free. So ideally, I want to only call it for on the pictures which contain human faces. So UWP has the out-of-the-box face detection technology. I would not go into detail on how it works. You can have a look at the sample code on GitHub. I will just show you how this sample code runs. So this sample code detects faces, and it will call this counter callback function as soon as if it detects the face. So here it is. If it sees the face, it does the countdown 3 to 1 and records the face and stores it locally. So if the person goes out of the view, it starts counting again, and in 3 seconds it will take the picture again. So that's the application which right now it doesn't do anything. You see on the right there is the placeholder for the cognitive portrait. But otherwise it just does local photographing of people. Here is the piece of code that actually decrements the counter, and once the counter reaches 0, it does some processing. And here we need to actually add the piece of code that will call the cloud and do the actual job of creating cognitive portrait. So this can be done using Azure Functions. Azure Functions is so-called serverless technology. And the reason it's called serverless is that you don't have to take care about the server where the function will run on. You just say, I want this piece of code to run in the cloud, and that's it. So this Azure function, you have the link to documentation here, by the way, if you want to learn more about them. The idea is that the Azure function reacts to some specific event. For example, if you place the picture in the blob storage, it can fire the function. For example, one of the usages would be if you want to detect faces on all pictures you store somewhere, or if you want to put the timestamp on the picture, things like that. Azure function can also react to HTTP REST call. So the easiest, in our case, that would be the scenario. I want to call this as the REST service. It does the processing and returns me back the result. The idea is that for serverless functions, you don't need a dedicated server. You just say, I want this code to run in the cloud, and you only pay for the amount of execution. So you pay for the number of calls essentially of this function. So to create the Azure function, the Azure functions are not, they are also the way you think of software. So you can develop Azure functions locally. You need to install the Azure functions runtime, and then, for example, from the command line, you can create this function using those commands. Let's see how this can be done. So right now I have the Azure function CLI installed. So I would say I want to create a new new function called coportrait in Python. And then inside this coportrait can contain several functions. I would create the new function called pdraw, which would be based on HTTP trigger. Now I can start the function locally. If I start the function locally, I would essentially get the environment. I would need the local Python environment installed, of course. I would have this local Python environment, and I would be able to call this function and see how it works. So, for example, right now it's open on port 7071. If I go to this port, you can see that there is a web server available at this port, which will tell me that you have the new function up running. And to call the actual function, I would need to say /API/pdraw, which is the name of the function. And here you have some kind of response from my function. And why do I get that response? Because it's hard-coded inside my Python code. So my Azure function is defined by essentially two very important files. One of them is the function itself, which is by default would be placed in the init.py file. And you can see that this function call this function is defined by normal Python function called main. And this function has some input arguments. So in this case, because it's HTTP trigger, it receives the request argument as the input, which contains all the parameters like get and post parameters, and it gives me back HTTP response. And what I do here, I get the parameter called name, and I give the response hello name if I had this parameter. If not, I just say that query needs some parameter, and I return the status code. So that's the logic of what I want to do. One more important file is called function.json, and function.json describes the bindings. So bindings are something which allows the function to get some data from the cloud without explicitly writing code for that. So in my case, I have this one parameter called request, and the reason I have it is that I described my function, I described this parameter here. I say that I would have the parameter called req. So this name corresponds to this name here. And it supports method get and post. If I want, and I also specify the output parameter. I say that the return of the function would be the HTTP response. If I want to bind the function to some other data inside the cloud, for example, to some blob storage, I can do this in this function JSON. So I would just write another parameter here, and I would provide a parameter inside my Azure function. So for my specific case, I want my Azure function to draw the cognitive portrait. So how it would work? First of all, I take the incoming image and I store it somewhere in the blob storage. To work with the blob storage, I have the Python API, and you have the link here on the slide to this Python API if you want to more details on that. But it's pretty simple. I take the name of blob service and I get the body of my request. And then I store it inside the blob storage. So the clever thing here is that I would need to mix together the last 10 pictures submitted by users. So to do that, I need some kind of way to sort blob entries by date. Unfortunately, by default, the blob entries can only be returned by alphabetically. So I need to devise some kind of clever naming so that files are displayed in the alphabetical order, and the last files would be the first one to be displayed using this alphabetical order. So what I did here, I did some clever naming. I compute the number of seconds till the year 2021, and I prepend this to the file name in the beginning. This is not the best way to do it, because I would have the year 2021 problem here, but that's the one that came to me. So I store the incoming picture to the blob storage. So the next thing is to do the fine transformation. So what I do here, the second thing would be to call the cognitive services to retrieve facial landmarks and do the fine transformation. So to call the cognitive service, I use the same kind of code that I showed you earlier in the Jupyter notebook. Detect with stream. Essentially, I provide it with the stream of bytes with my picture, and it gives me back the result, the information of all the faces. And if the result is not none, I would do the fine transformation, and I would store the resulted image into another blob storage. So here I do it. So I would have another blob storage which contains all the images already aligned. So then, to create my final image, I just need to take 10 last files from this blob and glue them all together. So this can be done using this clever piece of code. So I say blob list blobs. That gives me the list of all files in my blob. I take only 10 first elements, so this can be done using iter tools, and then I get binary from blobs and decode that into images. So this one piece of code gives me the arrays of all images, and to create the blended image I just need to call np.average on them, and I store the results somewhere in the third blob. So here I do it, and I return the URL of this blob. This third blob is public-facing blob, so everybody can access elements from this blob, and I just return the URL which everybody on the internet would be able to download and use. So let's see how it works. Here I have the same piece of code that I showed you earlier in Visual Studio Code. I can then say function start. You have already seen that, but I have changed the code. So now I'm starting my actual Azure function, which does some work. And I can use I can call this API and provide it with the binary image. So I would say binary. I would select some image that I want to post to this Azure function. And I would say send. So Azure function, you can see it will run. I have all the information which I can use for debugging, for example, and it would give me the result. Here is the resulting URL. If I open this URL in the browser, let me see it. I would get the blended picture. So once I have the function running locally, I need to publish it to the cloud. To do that, I need to create the function resource in the cloud, either using Portal or from the command line using Azure CLI, and then do publishing from command line, and finally handle all possible errors. So let's see how this can be done. I will add a new resource to my resource group. Let's search for function up to quickly find what we need. And here we go. We click create. We need to provide some parameters such as function name. Let it be coportrait. Then I can choose whether I want to deploy the code or the ready-made container. I will deploy code because that's a little bit easier. I need to select programming language and then the location for the function to run. And the consumption plan, I will use serverless consumption plan. It means pay as you go. If I want more control, I can choose the virtual machine based consumption plan as well. And finally, I click create. It takes a little bit of time to create the function. And I will end up with this resource, coportrait, available in my control panel. Right now, if I try to go inside this coportrait, I would see that there are no specific functions inside there because I need to deploy them. And this can be done from the command line. So I go to my directory and I say that I want to deploy the functional app. And what it does, it packages my current directory as one package and puts it on the Azure portal. Once we have the Azure function up and running locally, we need to put it into Azure. To do that, we need to create the function app object in the cloud, either using CLI or from the portal. then publish the function from the command line, and handle all possible errors which typically come from different library versioning. So let's see how this can be done. I add the new object to my resource group. I search for function up. That's the easiest way to find what I need. And here it is. I click create, and then I need to put a few parameters in, like function up name, coportrait. I can choose whether to run it as a Docker container or as code. Code is probably easier, but if I want the complete control, I can provide my own Docker container. Then select the location, and pretty much all the rest can be left as default. I will also select serverless consumption plan, which means pay as you go. And that's pretty much it. I click create. It takes some time to get this function up running, and at the end what I get this empty container called coportrait, which does not contain inside it any specific functions. You can see that right now functions is empty, and to put my function there I need to deploy it. This can be done from the command line, from the same directory where I put my local function. I just click this command, and it packages everything, all my code, into one package and does the deployment. So the only tricky thing here is that the function would be running in the different Python environment. So you need to make sure that you have versioning in requirements.txt correct, and otherwise you can get a few incompatibility errors there. So this can take some time. I will skip a little bit of this process. But once the function is created, it will show me the URL. And this URL, together with the code, can be used to call this function. So let's see how we can do that. Using Postmaster, we can provide this URL instead of the local one. And now we have this code running inside the cloud successfully. And let's make sure that it still produces the correct images. Yeah, we can open the image, and here it is. Right now the image is empty because that's the first invocation of my function in the cloud. So now that we have the function running, we can add this function, we can add the portrait functionality to our UWP app. So if you remember, UWP app was able to take the photographs, and once it takes the photographs, we can now introduce the remote function call here. So what I will do here, I would put the piece of code which does the REST call using HTTP client. So this function to do the REST call would be called call cognitive function, and then I assign result to the correct bitmap. Res would be the URL. So this call cognitive function, what it does the post request to my Azure function, and Azure function URL is provided as function URL variable. So I need to make sure I paste the correct function URL here as well. So that's pretty much how easy it is to add this functionality to my application. Now I can start the application and see how it works end to end. So I take my picture, and the first time, of course, it takes a little bit more time for the function to run. So right now I have already fired the request to the cloud, and that's why it's kind of awkward waiting. But yeah, here you can see the result. Now it will go much faster because the function is already warmed up. In the serverless mode it can have some delays, and now you can see us playing with it. I can put a different face here, and you can see how the function takes this face and adds it to the overall portrait. So that's pretty much how this application works, and this is exactly the type of application which was running in the Electro Museum in Moscow in January before it closed for the pandemic. So what we have seen today, we have seen that clouds allows you to run pieces of code in the cloud without any problems. So you don't have to think like which virtual machine to spin up. You just say I want this piece of code to run as a function in the cloud. It also allows us to store data, because all the images that we have taken we easily stored in the blob storage, and we don't really care where this blob storage is located. We just have it available on the internet. Now, when the exhibition closed for pandemic, I thought that it would be nice to provide the same kind of experience remotely, so that people can create their portraits without leaving their homes, and they can enjoy this kind of blending together with other people. And to do that, I created also the remote cognitive portrait bot. The way it works is that in addition to the exhibit, which we have already seen, we can have the virtual exhibit scenario. And virtual exhibit can be provided either from through Microsoft Bot Framework, through Bot Platform, or it can be provided from web browser. And it can call the same Azure Function backend. We don't need to write any different code, because once we obtain the image, for example, from the bot, we can call the same Azure function. To host the web application, we can use another platform service, Add a Web App, but I will not show that in detail today. I will focus on the bot experience. So let's see how we can create the chatbot for that. So we go and we again create a resource. We type for web app bot. Create a bot, provide some information here, such as the bot name and all the required parameters. I will use the new resource group for the bot. What Bot Framework does, it allows you to develop bot as a web application. So pretty much it will need only logic from you. And for the logic, I can start with the empty bot or with the echo bot. Echo bot is the kind of bot which tells you back what you said. So it's very good starting point. So it's always a good idea to start with the echo bot. So if I start with the echo bot, it deploys automatically all the required elements into the cloud. And I end up having this bot available here, and I can even start experimenting with it. So I can go and say I want to test the bot in the web chat, and it spins up the chat window right here in the Azure portal, and I can say things like hello, and you see the bot replies back to me. So here in the overview section, it shows me that I'm now at the build stage, and I can download the bot source code to start actually putting my own functionality in. That's a good way to start. I download this source code as a zip file. Then I can unzip it to some local directory and start working on it pretty much. And this code is the Visual Studio project. So what I can do, I can jump right in and click on the EchoBot solution, and it will take me to the Visual Studio. So let's see how this bot code looks like. So in the EchoBot, you see it's typical web application. So it looks like the ASP.NET application. The main logic is inside echobot.cs. And there is one function called oldMessageActivity, which happens each time that the user types something. So what we need to do, we need to put our logic inside this particular piece of code. Because our logic is pretty simple, I need to call the Azure function. I can use almost the same pieces of code as I used for my UWP application. And luckily, this is also C#. So I don't need a lot of changes. I just reuse the code. So here what I do, I check if I have any attachments. If the number of attachments is more than 0, I create the HTTP client to do the post call. And I do asynchronous post call to my Azure function. And then when I receive the URL, I give it back to the bot as attachment. Attachments are handled by so-called cards. So I create a new hero card and provide the URL to the image. So one more thing that I need to do is to, when I want to test the bot, I can use Bot Framework Emulator. And bot frame accumulator is the local a local emulator to test the bot right away without deploying it each time to the cloud and connecting to chat platforms. And to use it, I need to grab the app ID and app secret. This is what I did earlier. So I grabbed those two from app settings JSON. And then I can start my application. My application would be running as the web application with correct URL for the bot API. So now I can say open bot. I can provide my URL to my bot, pretty much leave the default, and then I need to provide app ID and app password. Those are two things which secure the communication. So now I have the bot running. I can start talking to it. If I say hello, it tells me please post a picture. If I post a picture here, let's see how it works. I post the picture and it calls my Azure function. My Azure function prepares the portrait. That's why it takes so much time. And the bot gives me back the result. So that's pretty much how easy it is to create a chatbot. If you want to have the chatbot running in the cloud, I can publish it also right here from the Visual Studio. So I use existing web application because when I created the bot, it already created everything for me. So I select my project here, Blender 13, and here it is. I just click publish. And after it's published, I can test how the bot works inside the web chat. So right here, I can open my bot. It now runs inside the cloud. And let's start by typing like some message without a picture. And then if I upload the picture, now which one is better? Yeah, I choose this one. And you see, it gives me back the result. So now it's interesting to run this bot somewhere available to the public. So for example, I can tie this bot, I can connect it to Telegram chatbot. And to do that, I go to channels. And in channels, I can configure in a declarative way different connections. So for example, I would select Telegram. And to connect to Telegram, what I need to do, I need to create the chatbot in Telegram itself. So it actually, Azure gives me instructions, but that's how it's done. I chat with the bot called botfather. I say I want to create a new bot. I select the name for the bot. I select the name, and then I get the API token from here. So this API token I need to provide to bot framework here. I click save, and that's basically what is required to have the bot up and running in Telegram. If I want the bot to be running in Teams, in Slack, in Skype, the process would be very similar. I just declaratively connect the bot to this bot framework in the channels section. So now I can add this bot. Let's search for it. People Blender bot. And here it is. You can actually try this bot after my talk. Yeah. So you can find this bot on Telegram as well. It should be up and running, and you can send it your photograph and get your photograph blended together with the photographs of other people who are watching my presentation now. So that's how it works. I hope I have shown you that it's very easy to create chatbots in the cloud as well. And also, believe me, I would not talk about that. It's also easy to host web applications in the cloud. If you want to see the example of web application hosted in the cloud, go to this address, easyfi.net/peopleblend. And if you don't have Telegram, you can just take a picture of yourself from the browser and get it blended together with other participants. So here is in short, what I've talked about. I've talked about creating bots, creating web apps using cognitive services and Azure functions. All that can be easily done in the cloud, and that's the point of my talk, that cloud allows you to put different things together to achieve what you want. In this case, I wanted to achieve expressive, beautiful exhibit and create this exhibit for people to enjoy. And there are also a few other examples of the works that I produce using the same idea, when you can blend pictures together in different ways. I hope you liked that. I hope you enjoyed that. My name was Dmitry Soshnikov. It was a pleasure talking to you, and I really hope you have the great conference today. Thank you.